ACLs are one of the easiest CCNA topics to think you understand, until one tiny line breaks the whole answer. In this lesson, you'll lock in the mistakes that cost points on the exam and cause real problems on live networks, starting with the implicit deny. If you lock in top-down matching and the hidden deny any, you'll avoid a huge chunk of ACL mistakes. By the end, you'll know how to read them faster, place them correctly, and dodge the traps that show up on the CCNA. An ACL is just an ordered list of permit and deny statements that a router or switch checks against packets. You apply an ACL to an interface in one direction, inbound as traffic enters or outbound as it leaves. ACLs are read top to bottom and first match wins. The moment a packet matches a line, Cisco stops checking. For the CCNA, remember this rule: one ACL per interface, per direction, per protocol, so you can't stack multiple IPv4 ACLs in the same direction on one interface. If nothing matches, the implicit deny drops the packet silently. That's why one missing permit can kill traffic even when the ACL looks short and harmless. Say you want to block one host, 192.168.1.10, but allow the rest of 192.168.1.0/24. If you permit the subnet first, that host slips through because it already matched. So the specific deny has to come before the broader permit. In ACLs, the order is the logic. That's why named ACLs with sequence numbers are so useful. You can insert or remove lines without rebuilding the whole list. Standard ACLs match only the source IPv4 address. Extended ACLs can also match destination, protocol, and ports, so they give you much tighter control. For the CCNA, know the ranges fast. Standard ACLs are 1 through 99 and 1300 through 1999. Extended ACLs are 100 through 199 and 2000 through 2699. Placement is where people make easy mistakes. Standard ACLs usually go near the destination because they only match the source. Extended ACLs usually go near the source so bad traffic gets stopped early. Use a standard ACL when the source address alone is enough, like limiting management access. Use an extended ACL when you need to control a specific destination or application. Wildcard masks are the inverse of subnet masks. 0 means this bit must match. 1 means this bit can vary. For one exact host, use host 192.168.1.10. That's just shorthand for the address, with wildcard 0.0.0.0, and any means every address. For quick conversions, /24 becomes 0.0.0.255, and /26 becomes 0.0.0.63. Miss the inversion, and you'll match the wrong traffic. A great CCNA habit is simple. Say the subnet mask, then flip it to the wildcard before you type. Let's build a named extended ACL. Enter IP access list extended WEB filter, then add sequence numbered entries so the policy stays easy to edit. First, deny TCP from the source network to the destination on port 80. That blocks HTTP. Then permit TCP on port 443 and UDP on port 53. So HTTPS and DNS still work. After your traffic rules, add an explicit permit for anything else you still want. If you don't, the implicit deny is waiting to drop it. Then apply the ACL with IP access group on the right interface and in the right direction. Put it on the wrong interface or the wrong direction, and a correct ACL still gives you the wrong result. A very common standard ACL use case is controlling who can reach the V2Y lines for remote management. Build a standard ACL that permits only trusted source addresses, then apply it under line VTY with access class, not access group. That's a classic exam trap. For a secure baseline, allow SSH and disable Telnet. Don't send credentials in clear text. This is a real lockout risk. Get the ACL or VTY command wrong, and you can block your own remote access. If an ACL isn't behaving, start with show access lists. Check the entries, check the order, and see whether the match counters are moving. Next, use show IP interface to see which ACL is applied and whether it's inbound or outbound. Wrong direction is one of the fastest lab mistakes to make. You can add log to an ACL entry for more visibility, but be careful with debug IP packet. On a production device, it gets noisy fast. If traffic still fails, check 3 things: placement, wildcard accuracy, and whether an earlier line matched first. That's your ACL troubleshooting checklist. Cisco iOS password types matter because not all stored secrets are equally strong. Type 0 is plain text, Type 5 is MD5 based, Type 8 uses PBKDF2, and Type 9 uses script. Service password encryption turns some plain text passwords into Type 7, but Type 7 is weak. It's obfuscation, not real modern protection. For privileged exec access, use enable secret, not enable password. It's more secure, and if both exist, enable secret wins. Quick reminder, don't confuse weak hiding with strong hashing. A solid hardening baseline starts with strong secrets and lockdown management access. Secure the device first, then layer on the extras. Disable unneeded HTTP services and limit which interfaces or networks can reach the management plane. Set a proper MOTD banner, configure a domain name, generate RSA keys, enable SSH, and use local authentication or another secure access method. One easy gotcha. If you don't set the domain name first, SSH RSA key generation fails. Port security protects a switch access port by limiting which MAC addresses can show up on it. You can set a maximum number of MAC addresses, choose a violation mode, and use sticky learning to remember what the port has seen. Shutdown is the strict option. It can push the port into AR disabled, which protects the network but disrupts service until you recover it. To verify, use show port security and interface-specific checks. Look for learned addresses, violation counts, and current status. If you remember first match wins, the implicit deny, correct ACL placement, wildcard logic, and the difference between access group and access class, you've got the highest value CCNA takeaways from this lesson. That's the core of ACLs and basic hardening. Keep practicing the configs and verification commands, and you'll get faster every time. Next up, we'll move into wireless and the key ideas you need there.